Hello, everyone, and thank you for attending today's webinar, How RPKI Deployments Help Networks and the Internet, presented by NTT. I'm Rebecca Kushmiter, and I'll be moderating this webinar. Our speaker today is Massimo Candela, PhD, the Senior Software Engineer in Global IT Network Division at NTT Limited. Just before we begin, a few housekeeping notes. The webinar is being recorded, and it will be available to watch on demand within 24 hours. Time permitting, we'll follow the presentation with a Q&A session. Please submit your questions using the Questions and Answers tab on the left side of your screen. Now, let's begin. Massimo, please go ahead.
Perfect. So, first of all, hello, everybody, and thank you. I'm thankful that you're here and with us during this webinar. The webinar of today, we will talk about the Resource Public Key Infrastructure, RPKI. We will start by saying what it is, how does it work on a high level, and what can mitigate, how it was able to mitigate. We will see some network issues that were mitigated by RPKI, and we will continue to see what you can do, especially in terms of monitoring your operation. And in the end, we will see the journey of NTT during the RPKI deployment. So my name is Massimo Candela. I'm a senior software engineer at NTT. In particular, NTT offers a lot of services. However, I work in the global IP network, which is the network that you can see in this slide. We are a tier one, which means a large network, and essentially to make everything run smoothly, we need software. And this is what I do. I do automation and monitoring. And I am in the Network Information System Development, which is a team dedicated to this type of softwares. And why I'm starting from this, because the RPKI journey is also something that was not immune to from the need of software, and that's actually how I started to be involved in the RPKI deployment inside NTT. But let's start from the beginning. I know that the audience of this webinar is mixed, so I'm going just one slide to introduce some really basic. Forgive me for being so high level, probably also not super precise, but I want just to give basic keywords. Bear with me. So the internet is made of several networks, which are managed by various operators, and autonomous systems are the basically administrative domain under which one or more of these networks are grouped. And each autonomous system is identified by an autonomous system number, and these are keywords that we will need for later. Now, for all these networks to work together and create a global network, to create the internet, we need a protocol that is called BGP, which is the Border Gateway Protocol. Essentially allows the cooperation between this network, but more precisely, so each device on the network is identified by an IP address. We will not talk about that at all. However, you just need to know this, and the BGP essentially says, okay, if you want to reach this IP address, you need to reach this autonomous system, okay? In BGP, all the autonomous systems are announcing, and announcing is the correct term used, ranges of IP address or IP prefixes. Essentially, they are saying, hey, I'm offering services on these prefixes, and if you need to reach these services, you need to reach me as an autonomous system. Now, all of this to introduce what is the problem about this. This entire system is based on good faith or trust, however you want to call it, because BGP does not have anything about integrity and authenticity check, which means that basically I can say to be whoever. And also it does not have anything about, to prevent that somebody can edit the BGP updates, the attributes in the BGP updates. Also, there is no authorization check, which means that I can announce whatever I want. And I can say, like, imagine that there is a service on a specific prefix. I can also announce that prefix that is actually not mine, and I'm not even hosting that service, and collect some traffic that it was not supposed to reach me, but to reach that service. And there are various reasons why I may want to do that. One reason is probably the most common, because I did an error and there is a typo or something, and I'm announcing something that I was not supposed to, but still I'm impacting somebody else. Another reason could be that I want to do a man-in-the-middle attack, which is a bit more complex, and I want to essentially make traffic that is reaching the service pass through me, because I want to collect it or whatever. But more easily, I just want to drop that traffic. I don't want to do anything. I just want to attract some of the traffic and basically prevent some users to reach that service. These are some of the issue what this lack of authorization mean, or in general this type of attacks can do. RPKI focuses on this part here, on the authorization part. It does not solve all the issues, and but it is a good step towards mitigating a lot of this of the issues that come with BGP. But let's start with what it is RPKI. The resource public key infrastructure. It's basically a system that allows you to provide a publicly verifiable association between prefixes and autonomous systems. So the thing I was saying before, I can just say, hey, if you want to reach this prefix, come to this autonomous system. Now that claim has to be verified. So basically, how does it work is that this association between prefix and autonomous system are recorded in cryptographically signed object called route origin authorizations, or ROA, and they are stored in some public repository. Then if you are a network, can download this repository and can create a list where you basically have a list of validated association between prefixes and origin-as, and you can use these to do what is called route origin validation. Route origin validation means that once you have this list of valid associations, you can use that to filter or to make your smarter routing decision. Okay, and for example, there are three options. If you have an announcement that you see, basically an announcement of a prefix coming from a autonomous system that is not this association in the list, that is invalid and you can reject it. If instead is in the list, then you can accept it. And if it is not at all in the list, so let me correct it. I may have said something. If it's not in the list, it's unknown, so it's not found. Okay, so it's the classic BGP. But if there is an association, but the association is actually different, so it, for example, points to a different autonomous system, then we say that that is invalid. So can be valid, I found it and it's correct. Invalid, I found something but it's not correct. For example, it's a different autonomous system, or I didn't find anything, then classic BGP applies. Now, when I said that RPKI solves some of the issue, in particular about the authorization, creates this list of associated AS and prefixes. It does not do anything about path verification. And also, what that means is that somebody can still apply some of those attempt to attract traffic that it was supposed to reach for somebody else. For example, an attacker, what can do is to create a BGP update that has the correct origin as and put himself as the next op. So basically pretending that the attacker can pretend that can reach the real S with one op while it's not true, and say, hey, send me the traffic, I send it to him. In theory. Of course, these type of attacks are a bit more complicated in terms of propagation, but the scope of this presentation is a bit different. However, they are still possible. Also a bit more complicated because they introduce a longer path to start with, and shortest path is usually preferred path to follow. Another problem is that there is no assurance of what your peers will do. So imagine that you are in a network where you are the only one doing route origin validation, and nobody else is doing it. Then you receive some paths that they are valid and invalid. You discard the invalid. That's fine. But then when you send your traffic to the next hop, which is not doing, or to any of the other hops, which is not doing route origin validation, it can still select a path that is not valid. And there is a nice paper here that I cited here, that there is this nice image that can explain this pretty easily. So imagine that there is the autonomous system 1 and the autonomous system 666 that is doing an attack on the autonomous system 1. The autonomous system 1 is announcing a /16, and there is autonomous system 2 that does not do RPKI validation, route origin validation, and there is autonomous system 3 which does route origin validation. What you will see here is that basically the routing, the prefix /16 will reach the IS3. The IS66 does now a more specific prefix /24. And usually, because the longest prefix match applies, the more specific prefix is the one that has preference in the selection of the path that has to be followed. So by doing this /24 announcement, the S3 will receive from S2 both possibilities, /24 and the /16. Now the S3 is going to reject the /24 and correctly follow only the /16. Unfortunately, since S2 is not doing any RPKI validation, S2 still it's going to probably follow the /24 because it's the most specific that it sees for the same range. This is an example. So RPKI is an effort that works especially in a context in which more and more operators deploy it, and also in a context where it gives the most impact in terms of what is like collateral safety, usually it's called, when especially the core of the network, and this is the reason why many tier 1 deploy it. Anyway, why I just added this brief slide, because I don't want, I just want to clarify the scope. I want to clarify that it's not a solution for everything. There are other solutions that they are coming and they are under discussion. And RPKI is a good step forward, and is also a step that allows to mitigate many of these issues, especially the ones they are, for example, just error and they don't have particular malicious intent. Another important thing to understand is that this is how a ROA, well, a ROA has more than one or more association between prefix and autonomous system. And another thing that usually the ROA contains is a prefix length, and the prefix length is basically allows you to specify a ROA that has a validity, you can say, between this /21 and /24. And while it may sound like easy and so you can declare it and be done with it, is actually not so much safe to do that, because what you should do is actually create ROAs for prefixes that you are announcing, and not create anything that is wider than that. So don't create this kind of lazy ROAs. And the reason is because of the reason that I told you before, because essentially somebody can still announce a more specific prefix, okay? And if it only would announce the more specific prefix, then the RPKI would just mark it as invalid. But if it does also the pattern manipulation, so it does a combination of the two, is able to do the exact same hijack that it would do without any check at all. So basically, is able to announce a more specific prefix, which will take precedence, and there is no path length to compete with because you are not announcing it. And it would be even RPKI valid because he's faking, he's saying that he's reaching the other S with hop 1. This is just an example of what RPKI does not do and what best practice you can follow. So create rows of prefixes that you are actually announcing. Now, I don't want to focus too much on that. Let's just go and see how does it work, the so-called chain of trust. There are the 5 regional internet registries, which are, well, you know which one they are. They are known, and what they do is that they delegate, they allow LIRs, which are, I don't know, internet service provider, to be their own certification authority. And this means that they will in turn be allowed to create the ROAs. And this is a schematic of how the system works. So we have the root certificates, they are self-signed. And after, basically, with a private key, you can sign the certificate of an LIR, which with a private key can sign the certificate of its own ROAs, and you can validate the entire chain by using the public keys. And now, let's talk a bit about the adoption of this system. This is a screenshot from a website called RPKI Monitor of the National Institute of Standards and Technologies. You can see that for V4 and V6, what they do here is they compare data coming from route views, which is a data collection platform that collects essentially BGP updates and dumps, and compare those data with RPKI data, and so basically do the validation of the various announcements. And we can see that for both V4 and V6, we have a 40% of RPKI valid. There is also a 55% of a RPKI unknown, which was the case I was saying before. Basically, there is no definition, there is no ROA covering that prefix, which essentially means they are not contributing to the RPKI effort. And there is also a 1% V4 and 5% V6, which is a big number if you ask me, that they are actually RPKI invalid. And this 5%, it may kind of show that maybe some of these actors, they are actually not really monitoring whatever they are doing. And this can result in some time to actually realize it. And also this, it makes me think this mostly also because of the difference between V4 and V6. There is a possibility that V4 has a, let's say, tighter reaction time for people that they are not actually able to reach some services, and so they are complaining maybe sooner. I don't exactly know the reason, but we will see about monitoring later. Now the question is, does this RPKI work? And I thought it was funny to show some cases in the past, and let's start with one, which is, this is no RPKI. This is the case of YouTube and Pakistan Telecom in 2008. This is a kind of, it's basically the case that is used every time to show how a hijack works. It's kind of textbook case. And I think there were other cases before this in the history of routing, but I believe that this is used mostly because there were at that time data collection projects available, and also visualization tools like BGP, which is the one that you see here. So it was possible to reconstruct it completely. And you can see here, these two, all these dots, all these balls here are the autonomous systems. All these dashes here are how they are the path connected. And you also see these two autonomous systems in red, which are originating the prefixes. One is connected already, which is the YouTube one, and one is still red but not connected yet, because at some point it will start to hijack the prefix. So this line here, you see the number of BGP updates, and before this peak, you can see I selected with in red. There is a time cursor which I selected. This is before anything happened. So before the attack, we see YouTube announcing his on /22, and nothing happens. What happens at some point is that Pakistan Telecom, probably for a request of the government to censor YouTube, started announcing a /24, and which is a more specific, and as I was saying before, more specific than takes precedence in terms of traffic. And you will see here that the /24 appears and just starts propagating. Of course, the /22 is still an option and remains connected, but from a traffic point of view, all this autonomous system here, that they are connected to both, they will follow the more specific way. They will follow the /24 and then send this to Pakistan Telecom. This was probably supposed to be effective only in the region, but indeed this propagated globally and was visible from everywhere. And then what happened is that YouTube at some point started announcing the same /24, and you see various path changes that re-gave a good amount of the traffic back to, a good amount of the visibility back to the YouTube OS. However, the real solution happened when YouTube started announcing 2/25 more specific, and we can see here that basically everything is back to normal, because these are yet more specific than the /24 of Pakistan Telecom. This is a base case of no RPKI. Okay. Now I wanted to compare it with this other one, which I selected on purpose, which is the RTCOM and Twitter. This is really recent, 2022. And we have here a similar case, because also in this case is probably censorship of YouTube in this case. And what happens is that what you see here is the normal YouTube autonomous, Twitter autonomous system. And here in the bottom, at the moment, isolated the RTCOM autonomous system. And what happens here is that at some point, the RTCOM autonomous system starts announcing the /24 that Twitter was using. However, at this time, Twitter had ROAS, and we can see that the propagation was, I would say, really limited, and from autonomous system that they were probably not doing route origin validation. Now, this is how RPKI can mitigate this type of things. And last but not least, this is a case that was suggested to me by a guy that in our community knows something about measurements and data collection, is really an expert, which is Doug Madori. And he gave me this example, which actually is really interesting because it's the opposite side of the coin. In this case, what we have is a rainbow network that was using some prefixes apparently belonging to CenturyLinks, and it was announcing those prefixes, but there were no ROA at that time for those prefixes. So this is why I say it's the opposite, because the ROAs were created to actually mitigate this. And you can see here in the bottom that also NTT and other upstream providers, they are propagating these prefixes because there is nothing against it. And I mean, it's at this moment, those prefixes are unknown, are not found in the validated list of association that I was saying before. So at some point, CenturyLinks wants to gain back these prefixes, and what it does, it creates ROAs. And when the ROAs are created, the upstream providers that they were doing route origin validation at that time, this was 2020, like NTT, drops these routes. And we can see the same thing from this type of visualization, which is called upstream visibility, where we see the amount of visibility that passes through the various upstreams. And we have several upstreams, including we have Telia and NTT. At that time, both of Telia and NTT were doing route origin validation. So when the ROAs get created, the visibility is interrupted from these two autonomous systems. While Comcast, which is the purple one, which at that time was not doing it, but now is doing it, route region validation, basically keeps providing visibility to these prerequisites. So this is the counter example of when you create ROAS to actually fix an issue that is already ongoing. But only malicious attempts. Well, not only, actually, I do believe, as I already said, that most of these are probably, most of the issues that we see today on public BGP data collections are probably typos and errors, and this is where RPKI shines to fix those type of errors, where there is not a malicious intent that actually needs extra activity. So in this case, there are a lot of these that they are not malicious, and even the one that they are partially malicious, like censorship, not necessarily they were intended to disrupt traffic across the globe. And this is where also they can help. RPKI definitely helps in mitigating. Also, we all do errors, and that's essentially why you need to do monitoring. So we all do errors. Every time I hear stuff like about BGP monitoring and stuff like this, most of the people are focusing on hijacks, and like if everybody is attacking you, but the reality is that the first thing that you should do is to monitor yourself and prevent yourself from doing errors. So, and be aware of your own errors, be aware of them timely, and correct them. And if you notice somebody else doing error, do not propagate. And when you are, and you have, of course, to be aware of being impacted by other people's errors. When I say errors, not only before we saw that 5% of IPv6, which smells a bit like errors, but also we have this, I did a brief analysis, and I took 2021, all BGP data coming from RIS, analyzed how much time it takes from an RPKI invalid announcement to get fixed. And I explicitly took only the max length errors. Now, why this? Max length errors, they can, as we saw before, be part of an attack. However, they are also common error. And if thousands of autonomous systems are doing that, it's more likely that many of those are just errors, and not that we are in a giant war of hijacks. I did this 1 month sliding window, and on average, essentially, RPKI invalid, they take like around less than 1 day to get fixed in 40% of the cases, but the remaining one, it takes longer actually. And there are some that after like 15%, after 1 month, they are still not fixed at all. So there is a chance that there is no visibility on what's going on. And since also because RPKI deployment is still partial, maybe the routing is still working, it's just doing some crazy round trip, and operators do not notice that. So what you can do for that? Well, in 2019, I developed this tool called BGP Alerter that we released under NTT. Was initially developed for NTT. We decided it was a good idea to release it publicly, also to basically, I think everybody can benefit from it, and also we are going to benefit from it as a tier 1 if we see less shenanigans in the network. So more people will start monitoring their operation, better it is. It does provide real-time BGP and RPKI monitoring. It is easy to use because it has an auto configuration. There is no installation required. And it's just a binary that you run, and there is no data collection that you need to do because it uses public repository. What you will receive as an alert once you start monitoring with this list gets longer every presentation, so I just give some highlights. So you have, of course, the basic hijack, but you also have prefix visibility. You get informed if your autonomous system is announcing a new autonomous system, a new prefix that was never announced before, and you should check it. It is okay. Maybe, or you did a typo. That's the type of information that you can get from it. It will tell you if there is in an AS path a new upstream or downstream peer, and which can tell you, for example, can be normal, or it can be, is it somebody faking it, like the case that we saw before. Also, you get informed if you are announcing RPKI invalid, if you're announcing prefixes not yet covered by a RAW. So, for example, if you deployed RPKI, you can use this to keep your RAW creation clean. Also, you get informed every time that you do a change to any RAW. It is really nice to have this diff thing, because it gives you an information of when your changes are public and visible for everybody. And also trust anchor malfunctions. You may not care, but if you see RAWs disappearing, and you also know that there is a trust anchor malfunction, maybe you are not going to waste time debugging something that is out of your control. Maybe you're better just calling that your RIR and ask for information. Or if your RAWs are expiring, not only your RAWs, but also any of those components in the chain that we saw before may be expiring. And you may have benefits in knowing if something is going on. There was a case last year where a certification authority had a disk full that was impacting some of our RAWs, and they were going to essentially expire. And thanks to a notification, we contacted them and asked them what's going on, and they discovered there was a disk full that was preventing the renewal. So you go on the repository on GitHub, you go on the releases, there are precompiled binaries. You can compile it if you want, otherwise you just download the precompiled binary, and you download it, you run it, that's all. It's going to ask you a few questions like which AS you want to monitor. You want to get informed about new prefixes, you want to monitor your upstream and downstreams and stuff like this. When you answer these questions, it automatically creates a configuration for you, and then you will start receiving things like this. This is what we receive on Slack, but you can receive it in emails, whatever you want. There are a lot of integrations. Just something that makes me proud. We have years of experience in many production installations. Not only we use at NTT, but there are also a lot of good friends that they are using it in their network, and some of these are really among the most important internet players. And you can find a list of friends that they added their name in the list. Is something that makes me really proud. Also, it was cited recently by the OECD in a white paper about routing security as a tool used for network operators for monitoring. And version 1.32 was marked as released after various weeks of testing. Was marked as release on Sunday, this Sunday, which of course makes me question my life choices. However, the good news is that after 2 days, the Linux version itself was downloaded more than 830 times since then. So another thing, if you are really not keen, you don't want to have anything, you don't want to run any command line things, you don't want to install this software, as a personal initiative, I'm running a service called packetvis.com. You go on packetvis.com and you can get basically BGP Alerter as a service. As on top, you receive the same with on top AUI if you are lazy and you don't want to run this. However, it doesn't matter how you do it, but if you really are running, if you are operating on the network, you need to monitor your operation. Now, there is this RPKI and NTT part, which is the journey about what we did in our deployment. And what you can derive from here is some probably maybe even best practices and examples. So we started doing this in 2020 in March. This is the official announcement, and what happens here is that what we announce here is that we started doing route origin validation. So we start rejecting RPKI invalid announcements. However, we pretty soon realized that all these tutorials where they say, oh, you need to create the ROAS, oh, you need to do route origin validations, they didn't mention the effort needed for the day-to-day. So the RPKI requires some additional knowledge that you need to have in your stuff, and require also some additional procedures, which are these procedures for other type of technologies are, I would say, now known, but the community is actually moving towards a best practices for RPKI. And I hope that some can be derived also from this presentation. In particular, I analyzed the various mistakes. I had a feeling that some of these mistakes, like for example, prefixes that they are announced and they are invalid, they could be related to one basic idea. The basic idea that you announce this prefix and you forgot about the RPKI part, or you really believe that it's a new prefix that you are announcing, so it's going to be unknown. And this type of idea is actually wrong, because you should at least check if it's going to be unknown. If you already deployed RPKI, there is a chance that you have, for example, a less specific prefix that has a raw, and your announcement is going to be invalid. Another reason why RPKI invalids can happen is because you didn't forget about RPKI, but you forgot about the fact that there are some time component of RPKI, which is a publication time and a propagation time. And actually, there is a nice, really good paper that was released today that you can read, which has Roman Amrich and Randy Bush, that you probably know in the community, which they study exactly this timing. And it's really nice that they put numbers to this, because I have been talking about this since more than 2 years now. And for example, the publication time means that when you create a ROA, depending on the publication server that you use, it may require some time for the ROA to be visible. And in the meanwhile, you may be operating with definitions that they are not up to date compared to what you are announcing on the BGP level. And there are some, in particular, some certification authorities that I'm not sure if they still as of today, but in the past they had 24 hours period, which is pretty long, and is even worse if you create something that is actually wrong, and you realize that it's wrong when finally it's public and you see that there is an issue with it, and then you have to wait other 24 hours to get published, and I'm talking for experience, and then I mean, this is a problem. And another timing is the propagation time, which means how much does it take for the other operators in the network to actually do a RPKI validation cycle. Now, I reviewed our mistakes based on these ideas that I expressed in the previous slide. I review our mistake for the entire 2021. And again, this is us sharing internal data in order to foster the increase that knowledge about and maybe create best practices about this. I reviewed also the ticket that our NOC had to deal with, and there are mainly 3 cases for RPKI invalid announcement, which are the basic one. We were announcing something wrong max length. We had a less specific ROA. Now it's invalid. Second case, we announced a customer prefix. But they had no ROA for the autonomous system 2914. Since it's a customer prefix, the customer has to create ROAs. And so it's not really a problem. It's not an error. It's not a malicious intent of any kind. But still, it kind of gives you the idea that there is space for a new operation procedure that involves a communication with the customer. And the last was we migrated some prefixes from one autonomous system to another. But we didn't properly manage the ROAS. And this was a single event, which it doesn't really, you cannot derive so much out of it, but since it was involving quite some prefixes, that was involving 25.5% actually of the prefixes of these entire data sets. But we can describe it was a single event, but it's something that you have also to be aware of if you're doing things like this type of migration. The big one was almost 60% is the basic case, the wrong max length, the one that we also saw in the chart before, the one that, so basically is you have a ROA for a less specific and you create a more specific and you forget to update it or you don't update it in time. And also there is a 16, almost 17%, which is the customer thing where we announced customer prefix, but we didn't coordinate to create ROA. So there is space for improvement here. And what do we do? Well, first of all, software. As I was saying at the beginning, we introduce a new automation platform, which is based on the monitoring. And we improve the monitoring that you can benefit also from BGP Alerter. And we introduce a strict procedure to follow for example, creating ROAs, and we improved our communication with customer. We put all of this together. It's not a various points isolated. They are actually connected to each other. The automation is a portal, which is a UI on top of essentially on top of BGP Alerter, which allows us to see the status of all our prefixes. It's called IP Management Portal. And in addition to do that, allow us to create ROAs in a staged fashion. So before creating the real ROAs, we essentially create staged ROAs. We can after compare these ROAs that they are valid only in this environment with what we are announcing or what we are planning to announce on the BGP level. And essentially, 2 years ago, I presented these 4 stages of ROA. At the beginning, they are just staged, valid only locally, mixed together with the public one, the real one. We pretend that they exist. We see if everything is fine compared to what we are announcing or what we want to announce. Then we mark them as committed when everything is fine, which means that we can ship them to the real, for example, to the RIRs. And then when those are visible, so then when finally the publication time is over, automatically the system marks them as public because we get a notification, hey, this is a change that got applied. And then that's all. I mean, there is also a last stage, which is stable, which is just to close the entire ticket and to say, hey, this is okay for 24 hours, and that's all. When we deployed this, we got immediately benefit, and doing the same analysis for the next months, we realized that we got immediately in just a few months before, a few months after, 87% of reduction of incidents of that type. So key monitoring, create awareness on what you're doing. It's important. Now, I don't really want to bother you too much with conclusions. However, just a few lines: do route origin validation, sign your ROAS, and introduce procedures. They have to be clear. They have to be on paper. Every time you're planning to announce prefixes, and so to keep updated all your ROAS. So signed ROAS having max length matching prefixes that you are really announcing to avoid those issues that we were talking before. communicate with your customer if you are announcing prefixes or of your customer, and monitor your operation always, both BGP and RPKI. Check when your ROAS are finally public, so to be aware what the other people are at least able to see. Not necessarily they see that, because there is also the propagation time, but at least you know that they are at least visible. And check also what you are announcing, if you are announcing what you are supposed to announce, and also if you are announcing invalid. And of course, get notified, use software to get notified if your ROAS are expiring, if you have to renew that, or if you have to debug a situation where something is expiring independently from you. Now the webinar is over, surprisingly in time. I hope I didn't rush too much, and I think this is the moment where you can submit all your questions and I can answer, or I'll try to answer.
Great. Thank you so much, Massimo. We can move on to the Q&A now. I see we have a number of questions, and you can submit more questions in the Q&A tab to the left of your screen. We will do our best to answer as many of them as possible in the time we have left. Let's go ahead and start. First question, you said that there is a propagation time. How often should I do my RPKI validation?
Okay. So the this is a good question, and maybe there is some space for some I would say best practice to be mentioned here. So the idea is this: at NTT we do it every 15 minutes because there is a time needed for the validator itself, and this time is slowly growing for doing the validation itself. And the most up-to-date RPKI data you have, the better you can do. You can make your decision, and if you are monitoring, is even more important to have up-to-date information. And so I suggest something between 15 minutes and 30 minutes personally, but if for monitoring needs, it can go even lower, I would say. But if you do like something more than 30 minutes, like more than an hour, I personally would feel that you would have something that I would consider as low reaction time. And especially for monitoring, 1 hour would be basically useless. So this is... All
right, great. The next question, can the network affect your ability to correctly retrieve RPKI data, and how important is this?
Oh, okay. That's okay. So the network. So what you see, okay. The RPKI data is essentially you retrieve it by using the same network, and so this means that it can be affected by various things. So for example, it can be that a publication server is actually only doing IPv4, and we saw some of this, or that is unreachable at that moment, or stuff like this, or that is unreachable from you. Actually, this is an interesting case. We had a situation similar a few weeks ago, and I think now is a month, where we were doing monitoring, and there is a really good platform that is RPKI client offered by Job Snyder, which was having a node in Singapore that had a temporary issue, and based on that, we basically detected an issue with a trust anchor that was not there. And this is an example of what can happen. Now, if you are monitoring on a local scale, so you're monitoring for yourself, this is not really a big issue because you are experiencing what you see. But if you are, like in that case, monitoring on a global scale with multiple users, like in that case was the announcement was done by the service packet visa I was talking before. What we did there is to create a network of nodes that we compare the data. And so we don't base the RPKI validation used for monitoring only on one single node. But yes, the network can affect what you're able to see and what you're able to download.
Wonderful. The next question, does a company need a lot of resources to deploy RPKI?
Okay, that's really a good question. So the deployment itself, like in the terms of the technical part of it, like just doing the minimal of how it works, it is actually not expensive at all, at least I believe. What it is going to be more expensive is actually the knowledge in the team. The knowledge in the team and the knowledge that you need to keep that up day to day in a way that it doesn't start to be, it doesn't, for example, you do not start having issues like rejecting things that you were not supposed to, or for example, that nobody in your team knows actually what's going on, or why the validator stopped, or something like this. So the things that you saw in the last part of the presentation with the journey of NTT, I think that a lot of our cost was related to really understand how to make it work in the long run and combine it with our procedures, with customers asking services and delivering those services in time and correctly. I think is the daily workload that is probably more expensive than installing a RTR server and a RPKI validator. At least I believe. But anyway, I'm a bit far from the I would say the network hardware itself. So maybe somebody can also say that it's not so cheap, but that's at least what I believe.
All right, the next question will be our last question. Thank you to everyone who has submitted questions today. If we did not have time to get to yours, we will try and get to it in person later. For our final question, NTT is using Route Object and ROA to allow BGP advertisements with their customers. Is using ROA sufficient, or will we still need a Route Object in IRR database?
Good question. So I would both, because essentially, as you can see, there is still route origin validation is not 100%. We don't have a deployment that is 100%. So if you do both, you have more chances that to cover more autonomous system that actually they are using one of the two systems to do validation of the routes that they receive. So at least this is my advice. I would personally, between the two, at least do the ROA, but I think both is for now the way to go.
Well, thank you so much. That was our last question. And thank you all for attending the Spheres Telecom webinar and for submitting so many great questions. I'd like to thank Massimo for participating and NTT for presenting today's webinar. This webinar has been recorded. You'll be able to access the recording within 24 hours using the audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you at future events.
Thank you very much. Bye-bye.